Hello everyone. So this will be the simulation video for the differential gear design we have been assigned for the project. So we will be starting the design for the SolidWorks. So open SolidWorks and make an assembly, not a part. And okay, we are choosing the assembly because in the assembly you can parameterize your desired properties in the gears, and in the part sections you wouldn't be able to. So thus we are choosing in the assembly. So cut this and go to the design library. You will see an option for toolbox, and if you have already added in you have not already added in, you will be given a prompt for add in now. Just add in now, and you will be seeing many types of standards according to different countries and methods. So we will be choosing the ISO here, double click on it and go for the power transmission and then for gears. And we'll be needing the straight bevel gear and the straight bevel pinion. So let me first design the straight bevel gear. So drag it here in the window, and there immediately there will be some values to fix for this design of the parameter. And it will be very easy to design because you just need to fix the parameters and the design will automatically change according to your parameters. So let's say the module, let's keep it 4. The number of teeth, let's lessen it because the simulation is very hard to do for this that many teeth. So we'll be uh, lessening the number of teeth. And in uh, for just educational purpose I am showing this, but in your simulation you should use more and more teeth. It will be more accurate. Anyhow, I will be just giving 15 teeth on the gear, and for the pinion, the teeth number should be only 12. Don't worry, it looks like a pinion, but it is a gear. Mm, I'm just trying to make the simulation easy and less time consuming. That's all. And you have to remember the number of module, the number of teeth for the gear, and the number of pinion of the teeth, because these same values will be put it up for the pinion design as well, and also the pressure angle. These first four values are has to be the same for the pinion and the gear as well. So face width, I'm gonna change it. Hub diameter, I have to change it a bit. Let's lessen it up to 50. It's just the diameter of the shaft. And mounting distance, let's lessen it because if we keep that much big of a shaft, it will need so much more elements, and that will be not applicable for the design properly, and it will take much more time. So I will be lessening the mounting distance to just 50. Okay. And the nominal shaft diameter, I will keep it 20 because this way I will need less element on this shaft here as well. I'm just trying to make the simulation for the study purpose, for the educational purpose. During your simulation you must apply your own conditions in these parameters and make your own design according to your desires. So let's say the nominal shaft diameter, I'm gonna listen it a bit, 15. All right, so this will be our gear. Let me tell you, it looks like an pinion, but still. Now just try to remember these values. 4, module 4, pinion number of gear is 15. I mean, number of teeth for the gear is 15. Number of pinion teeth is 12, and the pressure angle is 20. Just try to keep it remember. Okay. And we're gonna need another gear as well. So I will just tap on it and okay. It will prompt you to do more, but you do not need any more. You just need 2 gears. And now cut it. Now it's time to design the pinion. Go for the straight bevel pinion and drag it here. Okay. So you have to change it as well. The model is 4, not a problem. The gear model was also 4. And now the number of teeth for the pinion was 12, and number of teeth for the gear, I remember it is just 15. Okay. and the pressure angle is what was 20. Face width was, let's say, keep it 20, right? I guess it was 20 for the gear. Anyway, let's change the hub diameter to 50. 80 is just the diameter of this shaft here, you can see, and mounting distance is 50. Nominal shaft diameter, I will be lessening the elemental elements for the simulation, thus I will be giving a large shaft diameter so that we don't have much element here. So let's say 15 again here. 15, I guess it's not okay. Just a little bit more, I mean little bit less, let's say 10. Okay, and it should be okay. Click and make another pinion and cross. Here you go. These are the four elements we will be needing for the differential gear design. Now go for mates, but before going to mate, you will see four components here. This is the four components I am showing here. So go for the first component, right click on it and make it float. So that's how you will be unfixing the gear or the first component, that will SolidWorks automatically fix it so that you cannot change it very much. So by doing it float, you can change the design right in your according to your mating conditions. So go to the assembly, go for mate, and now firstly make choose the origin and the first gear. Let's say this is the first gear, and select this cylinder and make them concentric. They are concentric now, and take, now choose this face and choose any of the plane that is properly parallel to it. So let's say the right plane and make them coincident as well, and take. Now what we will do is show the sketch for this one gear and one pinion. So go for, you can see a base revolve option in both part. So just show it. You can see the sketch for the both gear now. And similarly go for the pinion and change or show this sketch for the pinion as well. Now you can see the sketch for that will be revolve here. And basically what I did was this sketch here shows the cone, the concentric cone that is coincident on the teeth for the bevel gears. So I will be needing this cone to make this mating properly. Now what we will do is choose this line and choose any of the pinions axis line like this line and make them perpendicular. All right, and tick. And now choose the tip of the uh, choose the tip of the concentric cone, I mean this point and this point, and make them coincident and tick. You can see already the gear are properly mated here. Anyhow, we have to do it for the rest of the gears as well now, but before that I'll be choosing this plane and make another plane except the right plane to its parallel. Let's say the top plane and parallel, and okay. Now I guess it's okay. Now similarly, what we will do is make this line and this line to one of its perpendicular, and again tick, and this point to coincident, but what I have selected is not correct. Anyhow, so this point coincident, and now simply this whole point and their whole point to coincident, right? Okay, and now we have to oopsies, there's a problem, no worries. The gear has to be on the one axis, so keep this constant, this cylinder and this cylinder concentric, and it will be all right. See, and similarly make the pinions, these are called bores. So pinion bore, pinion 1 bore and pinion 2 bore also concentric. And okay, so you can see your design is complete. I guess I don't have any more mate to do. And okay, you can try rotating them. Well, you can see this rotates. You can see what happened to here. This can, you can see this rotates. You can see this rotates, and you can see what's the problem for the first. All right, you can see this rotates as well. Let's first hide the sketches. This sketches is being a problem, so hide the sketch. And also for the pinion, let's hide the sketch again. We don't need it. No, we don't need it anymore. And now you can rotate it freely. Rotate freely every gear here. Now the problem here is you can see they are intersecting like this, and that is not how a gear works. So we have to make another mates, we can say mechanical mates along for these gears. So go to the mate again and choose this face, and let's say this face, and go to the mechanical and go to the gear, and the ratio you will be giving here is the teeth number, because that's what the gear ratio is. Don't fall for this value teeth by diameter. You just need to give the teeth number of the two gears. So the gear for the teeth number for the gear was uh, 15, and the teeth number for the pinion was 12. And click OK, and you should see that. Okay, my bad. Before the mate, you have to keep it not intersecting. So just go undo and rotate it such way that it doesn't intersect. All right. I'm looking for only these two gears right now. So make sure that rotate such way that the teeth does not intersect. So now select this face and this face, and similarly go for the gear, and similarly give the teeth numbers here. So this was 15, and this was 12. You can see these were also altered now. Just go for the reverse. Uh, okay, the reverse won't work. So give this as 12 and they give this as 15. You can see the teeth number has altered. And now go for the mat, and I hope this will work now. See, the teeth are properly rotating each other. Now we have to repeat the same process for each of these gears. So I will be not showing this. Just go for this and this and this. But before mating, you should see there should be no intersecting part here. So rotate this at here, and so I'm going to show you one more. The rest of the two you have to do it for yourself. I guess you can do it. So select this face, and then go for a gear mate, and similarly choose the number of 15 and choose the number of 12. You can see they are altered again. So give the 12 first and give the 15 secondly, and you can see the properly are number mated and tick, and if you can see this also did properly, and this here as well. So see, the only one remains. You can do it yourself. I mean only two remains, like so this gear to this gear and this gear to this gear. You can do it yourself. Okay, so after mating you should see something like this. See, all the gears are rotating without intersecting. You can check for these teeth, no intersection. You can check for these teeth, no intersection at all. And you can check for these teeth, no intersection at all. So if you see some intersection, there are some issues with the mating conditions. So I guess you can solve that yourself. Now what we will do is to move to meshing, or let's say the actual analysis. Okay, so save it in your own files according to your device. So I'll be saving it. You should save it as an AGS file. So just go to here, save as, and let's name it uh, video gear, as I am making this gear for the video source, for the video sake only, and change the type to IGS here and save it. All right, now we'll be moving to the ANSYS. Okay, so this is the window for the ANSYS workbench. Now go to the static structural and drag it here down and export your geometry. I mean import. So browse your own geometry. Okay, so now I have imported the gear here. You can see a tick mark. After you have imported yourself, you will also see a tick mark there. That's not a problem. So let's go to the modeling now. I'm trying to make the video a bit short, so I'm skipping some parts that you can do it yourself. I guess you get that. Okay, so this is the gear. You can see it. And now what we will firstly do is to name some faces here. So you can see the gear names. So this is the first two gears and this is the last two pinions. So let's say we hide all of the last threes and my bad. So select this one, control, and hide all of them. Now let's say we are gonna give a load or the joint load of in this direction. You see, in this direction. So if I am going to give a load on this direction, only the faces of this side, this side, and this side will be one that will be in contact. And so you have to delete all of these contacts here. You have to give some manual contacts here. Uh, so this is not the contact actually. So you have to delete these and select on your own contacts. So I'll be showing one contact region for the sake of the educational purpose, and for the rest three you have to do it on yourself, and you have to keep it understanding where which phases of the gear will be applying the load. In this case I am showing it you here. Let's say I'll be giving the load on this gear, the first gear, in this direction. So only the faces here, this and this, will be applying the load, not this side of face. Okay, so let me apply it properly and let me show you. So select this, apply again, one face, select one face and then apply, and then choose it again and apply all of these side faces. Okay, keep the faces option on, otherwise the edges will be also be selected, and select these faces. See, not these faces, just this side of faces, because the gear will be rotating like this. Just look at my mouse pointer. I guess you will understand the load direction properly. All right. So next, these faces. So all this side of faces will be the one that will be giving out the load. I hope you're getting it. And you can also fast forward to it. And while selecting this, you also have to keep the control option or control key on. Now you can see as the teeth number was almost 15, so I should be seeing 45 number of faces, because for each teeth I have three faces. One this face, this small one, this face, this small edge, and this bottom flank face. So there should be 45 faces. You can see 45 faces. The number of teeth into 3. if you select more teeth, you should be see the 3 times the faces in the contact faces if you select it properly. Otherwise, it is wrong, and go for another check. So, if as our load will be applying in this direction, just look at my mouse pointer, and thus all of these faces will be that will be contacting in our target faces of the pinion. So target will be now the target will be this. Let me show all of them again. Um, so my contact region was this, and it will be applying the force on this contact to this pinion here. And which face will be the face will be the target faces? Let me show you it a bit clearly. These faces, these faces here will be the target faces because this face will push down to this face. So all of the faces like this, and this will be the target faces here now. So similarly, select just one face including in the member and click apply. And now you have to hide this body here, otherwise it will be constructing the view, obstructing the view, sorry. So select all of this and oopsies, hide body. And now go to the contact region and select this side of faces all. So you should make it a zoom and apply, go for select mode, single select, and choose this. Again, fast forward to it because it is a boarding process and you have to do it all for the other three contact region as well according to the load conditions. All right. So the my teeth number was 12, so I should see 36 number of faces selected. I see 36, so that is okay. And now the faces are have been selected properly. Now what you have to do is to change the type to frictionless and formulation to Lagrange, augmented Lagrange, and interface type to adjust to touch. I'll be not explaining why I have those given because the video is getting way too long now. And apply, and this is all done for the this contact region. So similarly, you have to select all of this contact region according to the load condition. I'm just showing you. I will be just showing you after I have applied all the contact region or fixed the contact region. So try to do it yourself. Otherwise, I will show you how to do it. All right. So now you have. I will show you how I have given all the other three contact regions, so you can copy it yourself. So I have shown you this one. This is the contact region 1. Now the contact region 2, it shows that, see, my motion will be done like this. This gear will be rotating like this. So according to that, the contact body should be the gear and the target body should be the pinion. And let's, if it rotates this way, these faces here will be pushing down on the these faces of the pinion. Just think about it and I guess you will get it. And thus the target faces will be these faces and the contact faces will be these faces. And for the next, it is these two gears and pinion. And let me show you that this gear will rotate this way, and thus for this mating, this gear face will be forcing these faces. And if the gear will rotate in this direction, and these faces will be rotating down on this gear. And now, thus this pinion is the contact and the gear here is the target, not the other way around. If you see the other way around, just go right click on this contact and you can choose flip contact and target, and it will flip the contact and the target. So I've already done it, so I will not be able to show it to you. Just understand that according to the rotation direction, I have selected the faces and the target body. So again, try to understand that this gear will be rotating in this direction. Thus, the gear will be rotating pinion here will be this in this direction, and these faces will be forcing these faces of this gear. So thus the target are the contact are these and targets are these faces. And lastly, for this side, you can see the gear will be rotating in this direction. The pinion will be rotating in this direction, and these faces here, these faces, uh, sorry, this zooming condition in the ANSYS is not really good like SolidWorks. Anyhow, so this faces here will be rotating these faces. This will be this gear one will be rotating in this direction. The pinion will be rotating in this direction, and these faces here will be pushing down on these faces on this gear 2. I hope you get this. Try to get it, understand your gear rotation, and you should be able to do it. And always keep the type to frictionless and formulation to augmented Lagrange and interface statement to adjust to touch. Okay, the contact part is almost done. Now there will be another part to add, which is the joint load, because without the joint load conditions or the constraints, you will not be able to rotate something in static structural. Rotate something, it is according to time, and thus it actually need the transient simulations, but those are much more complicated than we think. So we have to stick to the static structural option, but we need a special condition called joint constants. Now I will be showing you that how to apply those. Now select mode to single select, right click on here, insert. You can see joint part here, and you can delete this part here and go to the joints, and you should see a body ground option. So tap on it and choose revolute. Now you have to identify the each rotation for this each of this gear. Now the body to ground option, it selects that the your rotation has to be only along this z direction. It is already fixed. You can, if you see this, I hover my mouse here, it shows you that permits only rotation about the z axis. So the z axis is fixed here, but you can see the z axis is down in this direction for this gear. Wait, let me zoom it properly. You can see the z direction is in this direction. The gear will never rotate along this direction, so I have to change this direction along the axis of this first gear. So let's do this. Go for the reference coordination and choose the z direction and keep it where you want it. I am wanting in this direction, so I will be selecting this. Now you can see the z is along the axis of this gear, and apply. Well, there was still a problem. Wait a minute, let me do it. Oh, my bad. The I haven't selected the faces yet, so it is not understanding which body I am referring to. So go to the scope and apply these two faces, and it will get what body I am talking about. And now the select the reference coordinate system. I want the z direction into this direction, so I'll be clicking it there, and you see the z direction is along the axis of this gear now, and apply. Now similarly, you have to do it all for the rest of the three. So I'll be showing you one more, and for the rest you have to do it yourself. So go to body ground again, go for revolute again. You should see a second option here, and now select the faces, let's say for the pinion here. select these faces, and let's say apply, and change the Z direction to your required direction. Click on reference coordinate system and choose, let me single select, choose this Z direction into this direction, and it will change it to accordingly. And similarly apply, similarly do all for these two gear and pinion. Okay, now you can see I've applied all the four. You can see this revolute, the Z is along this revolute, Z along this revolute, Z along this, and this revolute, Z is along this. All right. So all of our contacts and connection parts are okay now. Now we have to move on to the mesh. For the mesh, you would need a very good intricate meshing for these gears, but I will let you show a bit rough one because I don't you video is just for the educational purpose. So apply the whole bodies along all, select all, apply, and let's give body sizing of 0.2 only, and change the behavior to hard and generate. All right, the mesh is done here. You can see the very coarse mesh, and it should not be applicable everywhere. So just let's just on it, go on it with it, but let's me change a bit much, or else it will not converge properly, and generate, and done. Okay, I will be just moving on with it. Now go to the static structural, insert, joint load, change this to first option, and told you that the rotation will be done or the moment will be given on this gear. So now change the type to rotational moment, and let's say apply. Now you see the direction, it is the opposite direction that I have considered to given the contact. So choose a negative minus, go in the table, come to the table data and say minus 100, a random value I'm giving here, and change this to also minus 100. All right, so I guess it's okay. In this direction it will rotate anyhow. And for the rest of the parts, also select joint load, but this time let's say select this one, this just type, give the type to just rotation, and you will give just the angular value, that's it. And remember the rotation one of the moment in was in this direction, and thus the gear here will rotate in this direction. So the rotation direction is already okay, so I'll not be giving a minus here, to just give a plus 90-degree rotation. You can also go for 180, 360, but that will take more time, so I'm giving a very small angle of rotation. Now insert joint load again and change it to third body, and you should see the body will rotate in this direction, this will in this direction, and this will rotate in this direction. All right, it should be opposite direction. Okay, so this direction, this direction, and it should rotate on this direction. All right, so it will be in minus, so change the type to rotation first, rotation, and change the magnitude to minus 90. All right, and now for the last joint rotation, again go to joint load, change the type to last body, and type to rotation, and this will rotate in this direction, thus it will rotate in this direction, so it's okay. So just positive 90. And all right, I have given all my conditions and contacts. Now thus you have to solve it, and you might need m- almost like 1.5 hours, because in my PC it will take almost 10 to 12 minutes. So in case for laptops it will take much more. So yeah, let's stop the video here and I will show you again after the results has been done. My bad. Before running the simulation, you should go to the analysis setting and turn on the large deflection. Otherwise, the rotation will not be simulated properly. So now, give the simulation a run. So it's taking a lot of time here. It is just 42% complete. I guess it will take a lot of time. And I show you what changes I have made. And the body sizing I have changed it to 0.1 because that mesh was way too coarse. So I'll be showing you a previous simulation I have run with the same conditions, because it will take so much time for this 0.1 meshing as well. So let me show you that. So this is the previous simulation that I have run on these gears. Let me show you the results. Let me show you first what if they are same or not. You can see the connections. All of them are applied accordingly. See, the load was applied here. This will according to do all the phases I have been. The contact and the targets have been fixed according to all of the rotation properly, as I have shown you in the video. And the joints as well are all done to uh, so that the z-axis is along the axial direction for the cylinders. It is done for all of these, and also the joint moment is given onto this gear, and according to that the rotation was given, the pinions and the gears as well. So the conditions are all of the same. You can look at it. The formulation is still on the MPC, two phases, all of them are same. So this was the results I have gotten there. So let me interpret it a bit, run the simulation. Right, let me increase the frame a bit so you can understand it properly. See the rotation, see the stress here. So I have gotten a huge amount of stress here, almost 400 ksi, which is way too much. And I have also did the math for this condition, and also the stress is not this much. So I guess it needs a better meshing to get proper results, because this is a very complicated mesh. I tell you. Um, so here it is. And the your after the simulation is done in this condition as well, the simulation should look like what I have shown you there, and I hope it will show you like that, because the conditions are all of them are just the same. So don't you worry. Try to do the simulations on yourself, and this is it. And just try to keep the simulation as easy as possible, because the simulation load is very high will be on your laptop. And try to keep the mesh on the teeth a bit finer and on the shafts a bit slower or bit coarser. I guess this will prove you a good result. All right, so this is all.